Okay, so we'll share my screen. Share. Okay, everybody can see my screen. You can hear my voice.
Yes, Doctor.
Okay, thank you for the response. Okay, so last week we have learned up to these slides. Okay, up to power calculation for the angle modulation wave. Okay, so before we proceed, let's refresh again about the power calculation in angle modulated wave. Okay, so I go back to the previous slide, which is about power calculations. So the general equation for power calculation in angle modulated wave, which is for the FM and PM, okay, frequency modulation and also the phase modulation. So in general, the power calculation can be defined as 1/2 VC square multiplied with summation of Jn square from -infinity to infinity. Okay, and from here you might wonder what happened to the resistance. Okay, remember the equation for power as usual. Okay, which is P is equal to V square over R if this is a RMS, or you can also use V square, or which is this is a peak voltage divided with 2R. Okay, so persamaan power sebenarnya masih sama. Okay, as I told you, dulu, kini dan selama-lamanya persamaan power masih sama. Okay, V square over R. So from here actually, if you look from here, actually there is R, ada R di bawah sini, dibahagikan dengan R. Okay, sebenarnya ada R, tetapi dalam konteks ini we assume that the resistance is equal to unity, which is equal to 1. Okay, and if you read in many literature books, when they define the power calculations, you didn't see any variable of R. Okay, you didn't see any variable of R because they assume that the R is equal to unity, which is equal to 1. Okay, sebenarnya ada R, resistance, of course. So this J is the relative amplitudes defined by the Bessel function. Okay, and when we do the quadratic summations from -infinity to infinity, we're going to see that something happened at the end, where you see from here VC square over 2, which is this is actually have another one R over here, which is we assume equal to 1. Okay, which is this is equal to VC. So you might wonder where does the J parameter, di mana J parameter ini? So according to the Bessel theory, one of the Bessel properties said that summation of J square from minus infinity to infinity is equal to 1. Okay, berdasarkan Bessel property. Okay, Bessel property ada beberapa. Salah satunya adalah hasil tambah kuadratik from minus infinity to infinity is equal to 1. Okay, so this is a Bessel property, one of Bessel property. So if J square, summation of J square from minus infinity to infinity equal to 1, therefore the total power is equal to carrier power. Nampak? So that means theoretically in angle modulated wave, either FM or PM, the total power produced in the angle modulated wave is equal to the carrier power. Nanti kita akan lihat sebenarnya secara teori hasil tambah ataupun total power in angle modulated wave equal to the carrier power. Okay, so this is the carrier power that we have looked from the previous slide. Okay, carrier power Vc square over 2R. So sekarang baru dia tulis R. Okay, so don't be confused. The R is still exists. R masih wujud. Okay, R mesti ada. Okay, so theoretically you will see later that this PC is also equal to the total power. Okay, kita dah tambah-tambah semua. We added all the components power. Finally, we get the total power equal to the carrier power. Okay, and if you want to look from the perspective of the frequency spectrum, okay, kalau kita nak lihat dari perspektif frequency spectrum, remember that in angle modulated wave, we have many sidebands. We have many sidebands. Okay, kita ada banyak sideband dalam angle modulated wave. Okay, so theoretically when we want to calculate the power, we need to add all the power components. Kita perlu tambahkan semua power component. Okay, kita tambahkan one by one. Okay, macam yang kita belajar dalam amplitude modulation in the previous topic. Okay, so you see that the way we calculate the total power can also be done by summation of all the frequency component. Okay, this is P0 plus 2 times P1, P2, P3 until Pn. Kenapa darab 2? Because we have two sidebands, upper sidebands and the lower sideband. So dia sepasang. Okay, dia sepasang. And remember that the way we calculate the power for the sideband, P1 for example is equal to V1 square over 2R. This one. So how does we get the value of V? V here is the amplitude and J is the relative amplitudes. So in general, you see that from the equation of Jn is equal to Vn over Vc. Okay, ini yang kita dapat dalam Bessel function. And from Bessel table, kita dapat J. And if you want to find the amplitude, the real amplitude is Vn. So is equal to Jn multiplied with Vc. Okay, what is Vn? Vn is the real amplitude. What is Jn? Jn is the relative amplitude. Ada dua perkara yang sedikit berbeza. Okay, so ini pun telah dinyatakan di sini. Okay, so P0 is V0 square over 2R. This one. What is V0? V0 is equal to J0 V0. This one is square. Okay, similar with V1, which is J1 J1 sorry VC J0 VC sorry J0 VC. This one is J1 VC square. This one is J2 VC square. This one is J3 Vc square up to Jn Vc square. Nampak eh? So another we can see from here actually this part Vc square over 2r. Okay, Vc square over 2r. Apa itu Vc square over 2r? So Vc square over 2r is equal to the carrier power. Adanya komponen PC di setiap bahagian. Okay, adanya komponen PC di setiap bahagian. So kalau kita kembangkan, maka persamaan ini menjadi J0 square PC plus 2 times J1 square PC, J2 square PC, J3 square PC, Jn square PC. Ini kita tambah semua. We added all the frequency component powers, the powers of each frequency component. Kita tambah semua. Okay. So at the end, you will see that the total power is actually equal to PC. Pada akhirnya, kita akan dapat secara teorinya, total power akan menjadi sama dengan PC. Okay. So if you ask me, can I define the total power equal to PC in the exam? So persoalannya, adakah boleh saya buat seperti ini dalam exam? Jawapannya boleh. No problem. Tidak ada masalah. Okay, boleh. Because theoretically the total power is equal to PC. Of course. Okay. And from here, you see that, okay, dari sini kita akan lihat this statement. This statement say that the total power in the carrier and the sidebands components is approximately equal to the unmodulated carrier power. Dalam statement ini, dia nyatakan seperti ini . So dia katakan di sini approximately equal. Dalam kes ini, nanti you akan dapat, sebenarnya you akan dapat perbezaan dalam beberapa titik perpuluhan . Okay, beberapa titik perpuluhan berbeza dengan carrier power. Kenapa macam tu? Kenapa tak dapat sama dengan PC? Why? Okay, so the answer is like this. When you calculate the total power, so I go back to the Bessel parameters. I go back to the Bessel table. Okay, this table, remember this table. If you remember this table, salah satu perkara yang telah dilakukan adalah this one. Sideband with relative magnitude less than 0.01 have been eliminated from the table. So nilai-nilai kurang daripada 0.01 telah diabaikan dalam table tersebut. Walhal sebenarnya ada, okay, tetapi dia tidak signifikan, sangat kecil. Okay, so when you use this Bessel table to calculate the total power, okay, what you will see that the total power, okay, kalau kita gunakan table ini dalam nota, kita sebenarnya akan dapat approximately equal to PC. Approximately equal to PC here means that dia cuma berbeza beberapa titik perpuluhan sahaja. Okay, contoh kalau PC sama dengan 10 watt, mungkin you akan dapat dalam 10 point, for example 0.03 for example watt. So approximately equal. What I mean here is that nanti you akan lihat bahawa nilai dia sama tetapi berbeza sedikit, very little from the perspective of a few decimal point only. However, theoretically, okay, secara teorinya dia adalah sama. Okay, so that's why dalam exam nanti you akan lihat bahawa markah untuk mencari total power ini tidak besar untuk angle modulated wave. Okay, the marks is not very big. It's not big because it's very simple. You can use equal to PC. Unless, melainkan, unless the exam in the question say that you need to use the Bessel table. So biasanya markah dia kalau disuruh guna Bessel table, cari nilai power. Contoh, use the Bessel table to find the power. That means you need to use the long equations. Okay, kalau diminta mencari total power menggunakan Bessel table, that means the question wants you to find to calculate using the long equations. Jadi menggunakan persamaan yang panjang dan biasanya markahnya agak besar sedikit. So biasanya soalan seperti itu nak membiasakan pelajar menggunakan table Bessel. Okay, bukan saja-sajalah, memang kita nak membiasakan pelajar menggunakan table. Okay, even that, if the question specifically asks like that, then use the table, no problem. But theoretically, if the question just asks find the total power. Okay, kalau soalan cuma tanya cari nilai total power, then you can use PT equal to PC, no problem. Tidak ada masalah. Okay, so I go back to the fast forward, okay, to this slide. Okay, later in the next example, you will see that about the evidence of this statement. Okay, kamu akan lihat apa sebenarnya yang dimaksudkan oleh statement ini. Kita akan lihat dalam example berikutnya. Okay. Okay, so now example 3.7. Okay, example 3.7. An FM signal is given as 12 cos 6 pi times 10 power of 6 plus 5 sine 2 pi multiplied with 1250 T volt. Determine. Ada jawapan, tak ada jawapan. So kita kena buat lah. Okay. So that means we need to do this example. Okay. So perhatikan class, when you are given a certain questions like this, I would suggest you to directly convert the given parameter. For example, in this example, you are given an equation of Fm. So from here, you can determine that this is actually Vc. Okay, so here is Fc, but remember that we need to divide with 2 pi. Okay, that means Fc is equal to, kalau kita bagi 2, maknanya dia akan jadi 3 mega. Okay, 3 times 10 power of 6. Okay, so that means the carrier frequency is 3 mega. Okay, 3 megahertz. Kita bahagikan dengan 2 pi. And then what? So perhatikan kelas, bahawa di sini they are using a big bracket. So as I always told you that please remember about this big bracket. Don't do careless mistake. Remember to write big bracket because all of these parameters belong to cosine function. Dia tidak terpisah. Dia adalah milik kepada cosine. So be careful about that. Okay, and from here you see that 5 sine. What is this? So this is, we know from the general equation, this is actually referring to the beta f. Ini kamu kena lihat slide sebelumnya yang mana dalam persamaan umum parameter di hadapan sine ini adalah beta ataupun modulation index. Okay, and then what? Sine 2 pi 1250 t. So this is FM. This is modulating frequency or message frequency. Daripada sini dah boleh tahu banyak parameter. Okay. So determine A, frequency of the carrier signal. Very easy. Okay, very easy. So frequency of the carrier signal kita dah cari tadi yang mana dia adalah bersamaan dengan 6 pi times 10 power of 6. You need to divide with 2 pi, and we already get this is 3 megahertz. Okay. And then what? Frequency of the modulating signal. Very easy. Directly we can get from the equations. Okay. So this is from here. So 2 pi times that 1250 divide with 2 pi. So you get 1250 hertz. Okay. Modulation index equal to 5. Okay, from the equation. Frequency deviation, delta F, how much? So delta F, remember that beta F is equal to beta F over Fm. So that means delta F is equal to beta F multiplied with Fm. So this is 5 multiplied with modulating frequency, which is 1250. Ini boleh carilah berapa. So 5 times 1250, you get 6250. Okay, 6250 hertz. Okay. So please open your calculator so that we can see from here. So okay. And then what? Power dissipated in 10 ohm resistor. So you are given R equal to 10 ohm. So find the total power. How much is the total power? So remember, this is a simple question. So you can see that P total is equal to VC squared over 2R. Okay. So this is equal to VC is equal to 12. 12 square divide with 2 times 10. Okay, so you get here 7.2 watt. Okay, cuba guna calculator. 7.2 watt. Okay. Ada soalan? Any question you want to ask regarding this example? If you want to ask question, please ask questions. Otherwise, I will move to the next slide. Okay, boleh tanya kalau tak faham, sila tanya. And I would suggest you to help me also to calculate using your calculator. Sometimes saya tersilap mengira, kadang-kadang saya tersilap kira. So biasanya pelajar yang beritahu. Okay. Okay, if you don't have questions, I move to the next example, example 3.8. Okay. Determine the unmodulated carrier power. Okay, for the FM modulator given that beta equal to 1. Okay. Then determine, okay. So first the question asks, find the unmodulated carrier power. That means the question asks, how much is VC? Okay, given that beta equal to 1, VC equal to 10, R equal to 50 ohm. Then determine the total power in the angle modulated wave. Okay, then determine this total. Okay, so this example actually wants to show you about the relationship between PC and P total. Okay, sebenarnya dia nak menunjukkan apakah perbezaannya sebenarnya. So in this example, actually what we need to do is we need to use the long equations in order to compare with PC. Yes? Okay. VDR. Sekejap lagi ni. Oh, betul-betul lah. Nanti aku letak dalam video. Tak boleh letak sini. Okay, so these questions, this example actually wants you to see the difference between carrier power and also the total power. Jadi nak tunjukkan apa perbezaannya. Okay, so yeah. So in this case, we need to use the Bessel table so that we can calculate one by one. And then we compare with PC. Of course, kita tahu theoretically we know that PT is equal to PC. But in this example, we want to show you what's the difference. Okay. So first of all, find PC. Very easy. This is PC is equal to VC square over 2R. So you are given VC, which is equal to 10. 10 square divide with 2 times 50. Okay. So you will get this equal to 1 watt. Okay, 1 watt. Ini boleh cuba use your calculator. Another thing is that we can calculate also the total power from the using the Bessel table. So if you are given the beta equal to 1, okay, that means the significant sideband would be equal to 3. Ini kalau kita kembali kembali kepada Bessel table. Okay, sekejap So you are given beta is equal to 1. Macam apa yang saya ajar sebelum ni, if beta equal to 1, that means you see from here it has up to 3 significant sideband. Okay, it has up to 3 significant sideband. That means n equal to 3. And we have here J0, J1, J2, and J3. Okay, so I fast forward to I go back to the slide. Saya kembali kepada yang ni. So that means we have 3 significant sidebands, and the carrier component J0 is 0.77. Sorry. J1 is equal to 0.44. J2 is equal to 0.11. Okay, and J3 is equal to 0.02. Okay, so remember when you want to calculate the total power, so sekarang soalan tanya yang ini yang kedua, determine the total power in the angle modulated wave. So this example is purposely want to show you the difference between PC and total. What's the difference? So here, so therefore we need to use like this. So that this is J0 square PC plus 2 times J1 square PC plus J2 square PC plus J3 square PC, because we have up to 3 sideband. Okay, so this is 0.77. Okay, so 0.77 square This one is 0.44 square plus 0.11 square plus 0.02 square multiplied with 1. Okay. So kalau kita kira 0.77 square 5929 plus 2 times ini berapa? 0.44 square plus 0.11 square plus 0.02 square, so you get 0.2061, okay, multiplied with 2, okay, plus 0.5929, so you get here is equal to 1.0051 watt. Nampak eh? So it is equal to 1.0051 watt. Very small difference. Okay, very small difference with PC. Sangat sedikit perbezaannya. Why is it like this? Kenapa? Again, because the Bessel table in your notes has neglect the value less than 0.01. So that's why ada sedikit perbezaan. Okay, and this is to prove the previous statement. Okay, you see that here not exactly equal because the values in the Bessel table has been rounded off because it has removed the value less than 0.01. Okay, so dia tidak menjadi masalah sebenarnya kerana total power adalah sama atau hampir sama dengan PC. Okay, so this example wants to prove the previous statement over here, okay, which is approximately equal. But why it is approximately equal? Because of the Bessel table. The Bessel table has rounded off the value less than 0.01. That's it. Okay. So if you ask me, can I again? Saya ulang. If you ask me, is it possible? Can I, if in the exam I calculate the total power to be equal to PC? The answer would be yes. No problem. Tidak ada masalah. Okay. If you have question, please ask. Otherwise, saya akan teruskan. Okay. Ini tak ada soalan so saya teruskan. Example 3.9. Nampak So, okay. Okay, this kind of example is, this is a good example, a good practice for the final exam. Because if you see the final exam, it has a structure like this. First ask about this, then this, then this, then this. So dia ada beberapa steps. Okay, and normally in the final exam, the sub questions is in sequence. Okay, we arrange the question in sequence so that first ask number 1, and then from number 1 you can move to the number 2. And then number 3, number 4, and so on. Okay. Kenapa seperti itu? Kita susun supaya jawapan daripada sebelumnya boleh digunakan untuk jawapan seterusnya. But be careful, if you answer wrongly in the first part, the rest would be wrong. Okay, itu bahaya dia lah. Okay. So, okay. In the final exam, one question is 20 marks. Final exam consists of 5 questions. Okay, where each questions for each chapter. Setiap chapter ada satu soalan. So kita ada 5 chapter, therefore we have 5 questions. And each question is 20%. Okay, 20%. So 20 is 20 marks. So 20 times 5 equal to 100. Okay. So example 3.9, in this example, BFMT is equal to 1000. 1000 as cos 2 pi times 10 power of 70 plus 0.5 sine 2 pi times 10 power of 4t. So from this, okay, is measured in a 50 ohm of antenna. Apa maksud dia? So kalau you lukis gambarnya, ni ada jawapan tak? Ni tak ada jawapan, okay. So if you draw the picture, this is actually related to the transmitter. Okay, ini sebenarnya berkait dengan transmitter. Okay, so this VFMT is supplied to the antenna. Okay, VFMT is supplied to the antenna, which is VFMT. Okay, VFMT dihantar kepada antenna, and this antenna will radiate the signal as the electromagnetic wave. Okay, so kita supply we supply the signal to the antenna. Antenna akan memancarkan gelombang itu ke dalam medium dalam bentuk electromagnetic wave. And so the total power is the signal is transmitted to the antenna, and this antenna, the antenna ini mempunyai resistance sebanyak 50 ohm. Okay, so from here we can calculate the power. Okay, daripada sini kita boleh calculate the power at the antenna. Okay, power pada antenna, because we want to transmit the signal. So we calculate the power at the antenna, the total power at the antenna. So normally when we mention about the total power, it is the total power at the antenna. Okay, pada kebiasaannya kita mencari total power pada antenna. Okay, total power yang kita supply kepada antenna. Nah, nanti kita akan lihat selepas daripada antenna, what happened? That one is in chapter 5. Apa yang berlaku selepas antenna? Selepas antenna, what happened? So that one you will learn in chapter 5. Okay. So back from here, you can see that from these questions, this is VC. And from here, we can calculate the FC. So FC is equal to 2 pi times 10 power of 7 divided with 2 pi. Okay. So this is actually equal to 1 times 10 power of 7 hertz, or it is equal to 10 megahertz. 10 megahertz. 10 kali 10 kuasa 6. So 10 mega, 10 mega. Okay. And then here is 0.5. This 0.5 is actually the parameter of beta F. Nampak? And then what? Here, 2 pi times 10 power of 4. So this is actually related to Fm. Fm is equal to 2 pi times 10 power of 4 divided with 2 pi. So this is actually equal to 1 times 10 power of 4, which hertz, or you can say that this is 10 kilohertz. 10 kilohertz. 10 kali 10 kuasa 3 ataupun 1 kali 10 kuasa 4. Samalah. Okay, 10 kilohertz. So what? So determine the following. Unmodulated carrier power. Dia suruh cari yang pertama, cari carrier power. So ini senang lah, carrier power. So carrier power, okay, so carrier power is PC. PC is equal to VC square. Okay, VC square over to R. So this is equal to, so 1000 square divided with 2 times 50. So you get here about 10 kilowatt. Okay, so 1000 square divided with 100. So you get 10,000, okay? 10 kilowatt. Okay. And then what? Modulation index. Modulation index ni dah boleh dapat daripada soalan direct, direct from the questions. Delta F is equal to 0.5. Selesai. Peak frequency deviation. So the question asks about delta F. Delta F is equal to beta F. F is subscript. F is subscript. Beta F multiplied with Fm. So this is equal to 0.5 multiplied with 10 kilohertz. Okay, so therefore this is 5 kilohertz. Okay, 5 kilohertz. 10K bagi 2 so jadi 5 kilohertz. Okay. Ini kalau ada soalan nak tanya, tolong tanya segera. Please ask question if you don't understand. I can explain again, I can repeat again, no problem. Okay. Jangan segan, jangan malu So ini adalah kelas yang santai. You can ask me question anytime. Okay, saya suka orang bertanya soalan, otherwise kelas ini akan sunyi Okay. So I move to the fourth question. Find the modulation sensitivity if 200 millivolt is required to achieve part C. So soalan tanya sensitivity parameter. So this is actually related to KF, frequency deviation sensitivity parameter. Okay, find KF if 200 millivolt is required to achieve part C. So how to do that? So remember that delta F, okay, ini part C is here, number 3. We want to achieve a delta F equal to 5K. Okay, find KF to achieve a delta F equal to 5K if you are given a voltage of 200 millivolt. So what is this actually? This is referring to the modulating signal voltage, Vm. Okay, if you remember that delta F is equal to Kf Vm. Ini ada dinyatakan dalam slide sebelum ini So I go back to the previous slides So I go back to the previous slides so that you can find where do I get this equation. Okay, so ini jauh di belakang this one, Kf Vm. Delta F is Kf Vm. Delta theta is Kp Vm from this equation. Okay, so I go back to the slide. Saya kembali kepada slide. Okay. So therefore, we want to find Kf. Okay, so therefore Kf is equal to delta F over Fm, delta F over Vm. Okay, delta F over Vm. So therefore 5K. So we get the answer from the previous questions. Delta F is beta F times Fm. So we already got this the answer from the previous question in part C. So it is equal to 5 kilohertz. Divide with Vm. Vm is given here in the question 200 millivolt. 200 millivolt. Okay, so if you divide 5k divide with 200 milli, you will get 25,000. Okay, so 25,000 hertz, 25,000 hertz per volt. Remember, the unit is hertz per volt because we divide frequency and voltage. Or you can simply write 25 kilohertz per volt. Okay, the unit is hertz per volt. Unitnya adalah hertz per volt. Okay, and then what? Calculate the amplitude spectrum. Cari nilai amplitude spectrum. Macam mana nak buat? Okay, so ini kalau nak cari amplitude, so you see that amplitude spectrum. That means we need to draw voltage versus frequency. Okay, V versus frequency. Dia bukan J. If the question asks find the relative draw the relative amplitude spectrum. So kalau ada perkataan relative amplitudes, bermakna dia minta pelajar melukis J versus F. Okay. So here, so there's tidak ada ruang kosong yang boleh saya lukis. So I need to open a whiteboard. Okay, saya perlu open whiteboard. So so I will open the whiteboard. Okay, so before that, everybody can see my screen, you can hear my voice. Are you still there?
Okay, doktor.
Okay, thank you for the response. Saya risau nanti saya cakap sorang-sorang. Okay, so you are still there, that's good. So I will explain from here sebab tadi dalam slide tu dah tak ada tempat kosong, so saya kena gunakan yang inilah. Okay, so from here, from the question you see that remember that so you are given a VC is equal to 1000 volt from the question. Okay, saya rasa kamu pun dah dapat Jamboard ni telah dihantar kepada email lah. So you can open anytime, and then you are given FC. Frequency of the carrier is given as 10 megahertz. And then you are given FM. You are given a beta is given as 0.5. Okay. And then what about FM? FM is also given. If you see from the questions, FM is given as 10 kilo. Okay, FM is 10 kilohertz. Okay, so go back to the whiteboard. Okay, FM is 10 kilohertz. So from beta 0.5, we can find N equal to daripada Bessel table. Kalau kita lihat, kita pergi kepada Bessel table. So let's look at the Bessel table. Okay, so from Bessel table, so I erase this one. So from Bessel table, you see that if beta equal to 0.5, okay, that means we're gonna get three components. The first is a carrier component, first sideband, second sideband. That means we have up to 2 significant sideband. Kita akan ada 2 significant sideband, 2 pasang, N equal to 2. Okay, So, and the relative amplitude is 0.94, 0.24 and 0.03. Okay, so saya kembali kepada slide tadi, bermakna daripada sini we get the value of J0 is equal to 0.94. Okay, and then J1 is equal to 0.24, J2 is equal to 0.03, 0.03. Okay. So the question asks, draw the amplitude spectrum. Apabila kita nak melukis amplitude spectrum, that means we need to know the voltage and also the frequency. Okay, kita perlu tahu voltage and frequency. Okay, so in order to do that, I would suggest you to draw a table. Buatlah satu table ringkas. Okay. So a table for Jn. Okay. Jn here is J1 from J0 and then Jn is 0.94. So this is voltage or amplitude. Okay, boleh juga kalau you nak letak amplitude ni saya letak amplitude dah senang sekejap. So amplitude so J0 is equal to V0 kita nak mencari V0, sorry. So V0 is equal to J0 times Vc. Okay, so this is equal to 0.94 multiplied with 1000 volt. So this is 940 volt. Okay, what about the LSB and USB? So tidak ada sebab ini adalah frequency center. Okay, located. So this is J0 is located at the center, so it is not located at the side bands. Okay. So I go to the next part, which is J1 is equal to 0.24. Okay. So we want to find V1 is equal to J1 times Vc. So this is equal to 0.24 times 1000 volts. So this is 240 volt. Okay. So where is the location of this side bands? So from the lowest side band, it is located at, okay, so this is Fc minus Fm. Okay, so Fc is 10 mega. Okay, 10 mega minus 10 megahertz minus Fm is 10k. 10 kilohertz is equal to what? 10 kilohertz is equal to 0.01 mega. So kita samakan mega and mega. Okay, so that means this is 9.99 megahertz. Okay, what about upper sideband is equal to Fc plus Fm, which is equal to 10 mega plus 0.01 megahertz. Again, 0.01 is from Fm, yang ini 0.01 is actually 10k, 10 kilohertz. 10K kalau kita tukar dalam mega dia jadi 0.01 mega. So that means this is 10.01 megahertz. Okay, the location is 10.01 megahertz. Okay, next is J2 is equal to 0.03. Okay, V3 is equal to J3 multiplied with BC. So this is 0.03 multiplied with 1000 volt. So this is 30 volt. Okay, and the location here is in the lower sideband. It is located at FC minus 2 FM. Okay, because this is the second sideband. Ini adalah sideband yang kedua. So maknanya dia bersamaan dengan 10 mega minus 0.02 megahertz. 0.01 darab 2 so 0.02. So this is 9.98. Okay. And then for the upper sideband, plus 2 FM. Okay, so this is located at 10 mega plus 0.02 megahertz. So this is actually equal to 10.02 megahertz. Okay. So from here, then you can draw, okay, daripada sini, then you can draw the amplitude spectrum. Okay, so maybe I need to, kalau saya lukis kat sini tak berapa kemas, so I move to the next slide. Okay, I move to the next page. So when you want to draw, again, as I told you before, what is the important thing for drawing? Apa yang perkara penting? Yang pertama, kita nak lihat satu, drawing itu betul. Okay. Yang kedua, kita nak lihat bahawa labeling itu betul. Dua perkara dalam lukisan kita nak lihat correct drawing, correct labeling. So for drawing, don't use ruler. Jangan guna ruler kerana membazir masa. Okay. So if this is the amplitude spectrum, that means I need to draw the axis. Okay, saya akan lukis axis. So amplitude spectrum, that means this is amplitude dengan unit voltage, and here is F. So since we are dealing with megahertz, so easy for me to use megahertz over here. Okay, and then what? So you see from the previous page, we have up to 2 sidebands, sehingga 2 sidebands. Okay, so that means, so I have the carrier component over here. Carrier component, let's say the carrier component is here. So carrier component, okay. So carrier component, and then located at 10 mega. Okay, and then 10 mega, the amplitude is 940, and then we have located at 9.99 and 10.01. Okay, so kita ada lagi satu yang ini 940 volt. Okay, and we have this one is 240. So 240, that means apabila kita lukis, kita perlu melukis dia kecil lagi smaller, which is this is agak-agak lah, so maknanya di sini, okay, this is 240. So it is located at 10.01. Okay, and then here is we can go from here 240 volt. This is 9.99. Okay, okay, and then the third sideband is 30 volt located add here. So 10.02. Okay, so this is 30 30. So ni agak-agak lah, dia kecil sikit lah. Sekejap, Oh, this is approximation. So again, don't use ruler. I just estimate that, oh, this is 30, must be smaller. Okay. So this is 30, this is 9.98 mega. Ini saya padat sikit. Okay. So you see that from here, this drawing is correct. And correct means here that we have two significant sidebands with one carrier component. So the drawing is correct. Labeling, first label the axis, amplitude versus frequency, correct. I label the voltage correctly. I label the frequency as well. So nampak saya label tiga perkara, axis, aksi I label the amplitude, and also I label the frequency. If we draw like this, you get full marks. Okay, full marks for the drawing. So any questions want to ask? If you don't have questions, I will move to the next question in the example. Okay, ada soalan boleh terus tanya, terus tanya. Okay, the next question asks about bandwidth 99% and approximately bandwidth by Carson's rule. Apa maksud dia? Okay, so dia tanya 99% of Bessel bandwidth and 99% of Carson's bandwidth. So mula-mula kita perlu cari berapakah bandwidth by Bessel, berapakah bandwidth by Carson. Okay, how much is it? So you see that mungkin saya boleh lukis so maybe I need to draw here so that easy for you to see. Okay, so the question asks 99% of bandwidth by Bessel and 99% bandwidth by Carson. Okay, so that means first of all I need to find bandwidth Bessel. This is equal to 2 times N times Fm. So ini sebenarnya bersamaan dengan 2 kali N adalah 2 because we have 2 significant sideband. Ini tadi we have 2 significant sideband. Times Fm here, how much? Fm here is 10 kilohertz. So this is equal to 40, so for 40 kilohertz. Okay, and then what? If 99% of the bandwidth, berapakah 99%? Okay, so 99% bandwidth Bessel is equal to 0.99 multiplied with 40 kilohertz. So this is around 39.6 kilohertz. 39.6 kilohertz. Okay, and then what? Find the 99% of bandwidth by Carson. So therefore, you need to find bandwidth by Carson. This is equal to 2 times delta F plus Fm. Ini ada dalam slide. So 2 times How much is delta F? Delta F we already find from the previous questions. If you see from here, delta F is equal to 5 kilohertz and FM is equal to 10 kilohertz. Okay, 5K and 10K. So I go back to this. So this is actually equal to 5 kilohertz plus 10 kilohertz. So 15 times 2 we get 30. Okay, 30 kilohertz. So therefore 99% of bandwidth Carson, that means this is equal to 0.99 multiplied with 30 kilohertz. Okay, so this is equal to 29.7 kilohertz. Okay, so we get the answer like this and this. Okay, ada soalan nak tanya? So dia tanya 99%. So 99% lah. Kalau dia tanya 80%, so we multiply with 0.8. If 70%, that means we multiply with 0.7. So it depends on the question. Okay. Okay, if you have question, you can ask. Otherwise, I will move to the next question. The next questions, what? So we have answered this, answered this. So the next question asks about power in the smallest sideband of the 99% of bandwidth. Ini kita kena lihat. So tadi kita dah lihat, dia kata apakah power yang what is the power in the smallest sideband? Power pada sideband yang terkecil dalam range 99% itu. Apa dia? Okay. So how to do this? Okay, how to do this? That means we need to look from the spectrum. Okay, kalau kita lihat spectrum, kejap. Ini tadi kita lukis . So if you look from here, okay, if you look from here, ini kalau from this, you see that this is 20 and 20. Kalau you lihat di sini sebenarnya dia punya bandwidth adalah 40K. 40 kHz pada asalnya. Ini sama macam kita dapat dalam bezel 40K. Okay. However, the question said that we have limit the bandwidth up to 99%. That means the bandwidth now is 39.6. So kalau 39.6 bermakna, ni saya buat color lain lah. So if 99%, that means it is somewhere over here where this is smaller. Okay, so this is 99% bandwidth, which is equal to 39.6 kilohertz. Okay, 39.6 kilohertz. Ini yang kita kira tadi. 39.6. Okay. So 39.6 is slightly smaller. Kalau kita buat dia punya kotak ini seolah-olah macam filter lah. Ada filter, dia cut off lah, dia buang ni. Okay. Dia bukan dia buang, dia akan ambil yang ni lah, 39.6. 39.6, remember that 39.6 is calculated from the center. Daripada center kanan dan kiri totalnya total distance is 39.6. Maknanya kalau you nak tahu satu bahagian, maknanya 39.6 bahagi 2 lah. Kalau you nak lihat di sini sekejap. So 39.6 if you divide with 2, it is 19.8. Maknanya separuh bahagian di sini mestilah 19.8. 19.8K. This is 19.8. Nampak So maknanya bahagian yang ini telah terkeluar. You see that this component has been removed. And we take within 99% itu, kalau kita lihat, sideband yang akhir itu dah terkeluar. Okay, sideband yang terakhir itu telah terkeluar. Kita cuma ambil yang 39.6 So kotak yang inilah kita ambil So this we take this within this component. 99, so this is 99%. Now, so if you see from here, that means we only have one sideband within this box. Dalam bandwidth 99% ini, kita cuma ada sideband yang ini, okay, satu sideband sahaja. Bermakna sideband yang kita tidak kita ada carrier component dan kita ada first sideband. Okay, dan kalau you lihat di sini, dia cuma ada satu sideband sahaja. That means we can take this power, the power of this. Okay, the question asks how much is the power of the smallest sideband. So the smallest is this one, 200. The first sideband is the smallest in this case. So maknanya kalau soalan tanya 99%, so the smallest sideband would be the first sideband. Okay, the first sideband power. Okay, which is equal to P1. Okay. So soalan ini juga pernah soalan seperti ini So this question, this kind of question has been asked in the previous exam. Pernah ditanya dalam exam sebelum ini. Yang mana kalau you lihat dalam bank soalan ni saya buat sikit saya tunjuk sikit je. Saya suka kaitkan dengan exam yang lepas. Okay, saya suka kaitkan dengan exam yang lepas. Kalau dalam exam yang lepas, dia ada beberapa sideband more than 2 sidebands Contoh saya tak ingat berapa. Okay, so I want to relate with the previous exam. Saya suka kaitkan dengan yang lepas. Sebab saya ingat banyak soalan yang lepas. Okay. In the previous exam there are many sidebands. Dalam exam yang lepas dia bukan hanya 2 seperti ini dia ada beberapa banyak lah. And when we calculate the 99%, okay, when we calculate the 99%, you see that saya guna gambar lain saya guna color biru lah. So when we calculate the 99%, so we can up to here. Ini contoh saya tak ingat ada berapa spektrum, tetapi apabila kita mengira 99% of bandwidth, okay, that means it is between this these boxes blue color dalam range yang ini. Nampak yang mana yang the last spectrum has been removed by the filter. So this is actually the story about filter. Ini sebenarnya cerita filter sebenarnya, yang mana filter itu dia cut pada 99. Kita sebenarnya dalam konteks filter, we are talking about the story about filter. The filter cut off 99%. So from the previous exam questions, when we calculate the 99%, that means the last spectrum would be removed. Okay. So therefore, from here, you see that the smallest sideband would be the third sideband. Ini kalau dalam example saya ni, saya buat 4 lah, 4 pasang. Apabila kita mengira 99%, contohnya, sideband yang terakhir itu telah terkeluar daripada filter punya region. Dia telah terkeluar. Dan kalau you lihat di sini, sideband yang terkecil menjadi sideband yang ketiga, the third sideband. Okay, that means the third sideband, third SB sideband is the smallest. So therefore, the smallest power, the power in the smallest sideband would be equal to P3. Power pada sideband yang terkecil. Berapakah power pada sideband yang terkecil? Kalau dalam example yang saya tunjuk ini, dia jadi 3 sideband, maka yang terkecil adalah sideband yang ketiga. Yang hujung lah. Sebab dia kecil, sebab amplitude-nya kecil. Nampak Dalam you punya example kita nampak satu. Sebenarnya kalau dia ada banyak, kalau nanti you nampak lah, kalau ada banyak, maknanya kita boleh lihat mana satu yang terkecil. Again, the choices of smallest sideband is depending on the amplitude value. Nampak bergantung kepada amplitude-nya. Dalam saya tunjuk yang ini, kebetulan yang hujung itu adalah amplitude yang paling kecil. So dia adalah yang paling small. Okay. So we go back to this example. Kembali kepada soalan ini, bermakna power in the smallest sideband. Okay, so ini kembali kepada soalan kembali kepada ini. So that means power in smallest sideband smallest sideband of is equal to P1, okay, which is equal to J1 square PC. Okay, so this is equal to, so J1, how much is J1? J1 is 0.24. Okay, 0.24. PC, how much is PC? PC is equal to VC square. PC kita dah cari rasanya tadi Rasanya tadi kita dah cari PC sama dengan 10K. We already find PC is 10 kilo. Okay. So PC is 10 kilo. That means this is 0.24. 0.24 times 10K. So that means 0.24 square times PC is 10K. Okay, 10,000 watt. So this is how much? So 0.24 square times 10K. So 576 watt. Nampak 576 watt. So this is the smallest sideband in the 99%. So perhatikan kelas. If the question say that, if the question just simply asks about find the smallest sideband from the original bandwidth. Kalau soalan tanya, apakah power pada smallest sideband kalau kita consider 100%? If we consider 100%, kalau kita consider 100%, if we consider the whole bandwidth, that means the smallest would be the second. kalau kita consider 100%. But now we are considering 99% of bandwidth. The smallest would be the first sideband dalam kes ini. So jangan keliru lah. Okay. So kita tengok soalan. Soalan tanya 99%. Apakah power pada sideband yang terkecil dalam 99%? Oleh itu dia adalah the first sideband. If the question asks, find the smallest sideband from the whole bandwidth, that means dia merujuk kepada sideband yang kedua. Itu je, beza dia sikit je. Okay. Do you have question about this? If you don't have questions, I will move to the next. Question. Kalau tak ada soalan, saya akan teruskan. Saya mengalu-alukan pelajar bertanya. If you ask question, that means you understand. Bukan you tak faham, you understand. Okay. You understand more than the others. Okay. So, the last questions, find the total power. Okay. Find the total power. So, macam mana nak buat? Total power, okay, total power. Find PT. PT is equal to PC. Okay. PT is equal to PC, which is equal to 10 kilowatt. Okay. So, boleh juga kalau you nak buat seperti ini. You can also do like this. J0 square PC plus J1 square. So, ini darab dua lah. Ada dua sini. 2 times J1 square PC plus J2 square PC. Boleh juga. So J1 tadi adalah 0.94. Okay, if you see from the previous, this is 0.94, 24, 0.03. Okay. So that means di sini saya buat di sini, so sama dengan 0.94 square. This is 10,000. Saya buat 10k lah senang. Plus 2 times in bracket 0.24, so 0.24 square. Ini 10k, 10k lah, 10,000 saya buat 10k plus 0.03 square times 10k. Close big bracket. So ini berapa kalau you kira? So maknanya 0.94 square times 10k. So this is 8836 plus, so 0.24 square times 10k plus 0.03 square times 10k. So plus 5855. So this is how much this is? Plus 8836, 9421. So 9421. What? Okay. Slightly different lah. It's slightly different. Okay. 0.94 square times 10k, 8836 plus 0.24 square times 10k plus 0.03 square times 10k. So 485 plus 8836, 9421. Okay. So either one, no problem. Boleh. You can write 10k or you can write 9421. So this is actually 9.421 kilowatt, or you can mention it as 10 kilowatt. Boleh?
So I get 10k.
Huh?
I get 10k.
You get 10k, gunakan yang ni ke? So saya ada silap kira ke? Okay. Oh, exactly. Oh, saya silap kira yang ini kot. Ya. Sebaik betul kan. 0.24 squared times 10k plus 0.03 squared times 10k times 2. Okay, ni 1170 ni silap sikit sorry. Terima kasih yang dah betulkan. So ini sebenarnya saya lupa darab 2, sorry. 1170 plus 8836. So 10,006. Tu sebab saya pelik kenapa saya salah. Lain jawapan dia. And 006. 10k lah. Sama aja. So you can choose either one, no problem. Okay, tidak ada masalah you nak buat PT equal to PC or you want to use the long equation, no problem. Because this question does not specifically wants you to use a long equation, it's up to you. No problem. Okay. And kalau dilihat kelas, di sini dia bertanya tentang total power. Ada juga ditanya tentang find the sideband power. Ada juga soalan-soalan seperti ini find the sideband power. Okay, the question asks how much is the P sideband. If the question asks P sideband, find the sideband power, bermakna dia nak mencari total power from the sideband only. Okay. So sideband power is equal to, so we calculate, remember that we have, ni gambar aja, so kita kembali kepada gambar. So kalau ditanya sideband power, bermakna saya perlu tambah semua power pada sideband sahaja. Okay, that means P sideband is equal to 2 times, ni komponen yang tadi lah, J1 square PC plus J2 square PC. Okay, ini kalau soalan tanya find the sideband power. So kita kira power sideband saja. So kalau ada dua pasang, kita kena tambah semua sekali Okay. So that means 2 kali, ni tadi kita dah kira lah. 2 kali ni, so kita akan dapat 1170. Ni saya dah kira tadi 1170. Kalau ditanya sideband power. Kalau ditanya total power, kita kena kira semua sekali. If the question asks sideband's power, that means only the sideband. Itu beza dia. Okay, boleh faham? Ada soalan nak tanya? If you have question, please ask now. Okay, so I believe there's no questions. Kalau tak ada soalan, saya teruskan Okay, saya teruskan. Tapi kalau nak tanya lagi boleh no problem, you can ask me anytime. So saya boleh repeat, saya boleh jelaskan lebih lanjut, no problem. Ada soalan? Tak ada. Saya teruskan Okay. The next example, example 310. An FM signal with a 5 watt of carrier power is fluctuating at the rate of 10,000 times per second from 99.96 megahertz to 100.04 megahertz. Apa maksud dia? Dia gambar dia lebih kurang macam ni lah. Kalau kita lukis maknanya ada carrier power. So for example here is carrier. Sebab dia kata carrier fluctuating. Okay. So this carrier dikatakan dia punya power is 5 watt. So this carrier power is fluctuating from 99.96. Katalah 99.96 up to here, which is 100.04 megahertz. Okay, so dia fluctuates. Fluctuates means dia oscillate ataupun berayun daripada 99.96 sehinggalah 100.04 megahertz. Okay, ni macam inilah dia bergerak macam ni. Ya. So dia fluctuates. Okay. Dan kalau dilihat di sini, dia fluctuates sebanyak 1000 times per second. Dalam masa satu saat, dia berayun sebanyak 10,000 kali. 10,000 kali maknanya dia complete 10,000 cycle. Kalau you lihat gambar raja ni seperti gambar raja yang kita pernah lihat sebelum ni seolah-olah macam gambar raja yang ini. Ini saya back. Sorry saya back sekejap. Ini dah macam gambar yang ini. Nampak So the carrier fluctuates from tadi 99 point berapa tadi? 99.96, katalah sini 99.96 until 100.04 megahertz. So dia fluctuates sebanyak 10,000 times per second. Maknanya apa? Maknanya 10,000 times per second merujuk kepada frequency of the modulating wave. Sebab ini dia sebabnya modulating signal telah berubah sebanyak 10,000 cycle per second dan carrier fluctuates. So that means the VFMT already complete 10,000 cycle in 1 second. Dan carrier fluctuates based on the rate of the VMT. So kalau saya kembali kepada slide tadi, yang ini So therefore, these 10,000 times merujuk kepada modulating signal frequency ataupun message frequency. Berapa carrier frequency? We don't know. We need to know that carrier frequency is at the center. Okay? Ataupun dia berada pada rest frequency. So kalau dilihat di sini, carrier berada pada center daripada fluctuation itu. Okay, the total fluctuations, carrier must be at the center. Maknanya dia rest pada center. Okay? So how much is the carrier frequency? The first question. Carrier frequency, so ni kita kena okay. So maknanya carrier frequency, so you boleh tolak kalau you okay, kalau tambah pun boleh juga So FC sama ada you nak tolak either you want to use FC is equal to 100 contoh ataupun 99.96 plus hasil tolak 100.04 minus 99.96 divide with 2. So you akan dapat 100 MHz. Okay, atau you nak buat contohnya you nak buat FC equal to 99.96 plus 100.04. Okay, and then divide with 2 pun boleh. You akan dapat 100 MHz. Yang penting dia di tengah. So the center would be at 100 MHz. Ini kalau saya tengok congak pun saya dia boleh agak, oh FC ni dekat tengah-tengah, maknanya dia bahagi sama, maknanya dia 100. Congak pun kita boleh nampak lah. Tapi cara pengiraan dia seperti inilah. Either you want to use this or you want to use this method, no problem. Salah satu pun boleh. So that means the carrier is located at 100 MHz center. Okay. How much is the carrier swing? So carrier swing adalah jarak daripada jarak oscillation ini. Okay, so that means you need to carrier swing is equal to 100.04 minus 99.96. So this is 80 kilohertz. Okay, 80 kilohertz. Okay. And then what? The question asks frequency deviation, delta F. Delta F is equal to carrier swing divide with 2. So carrier swing bagi 2, you akan dapat delta F. Sebab sini delta F dengan delta F di sini. Okay, delta F dengan delta F, you akan dapat carrier swing. So that means 80K divide with 2, so you get 40 kilohertz. Okay, 40 kilohertz. And then what? How much is the modulation index? Beta F. So beta F is equal to delta F divide with FM. So this is 40K divide with 10K, because 10,000 times per second. Okay, 10,000 ataupun 10K lah, 10 kilohertz. So 40 divide with 10, so it is equal to 4. Bersamaan dengan 4. Okay. And then what? Power spectrum. Find the power spectrum. Ini satu hal lagi ni. Okay. Find the power spectrum for beta equal to 4. Fine. So yang ni penat sikit lah soalan ni. Okay, soalan ni agak penat. Okay. Kenapa penat? Nanti you akan nampak lah. Okay, kenapa penat? So remember kelas dia tanya power spectrum. Tadi kita dah lihat amplitude spectrum. Kita dah pernah lihat relative amplitude spectrum. So kalau power spectrum bermakna power versus frequency. Dia nak tahu power dan dia nak tahu berapakah frekuensinya. So ini kena guna whiteboard lah. So we need to use the whiteboard. So whiteboard, so let's do the whiteboard. Ini satu hal lagi kita kena, okay, kita perlu buat table lah. So maknanya kalau beta, if beta F is equal to 4 from the Bessel table, so let's look at the Bessel table. So kembali kepada Bessel table. If beta equal to 4, that means we're gonna have up to 7 sideband. Up to 7 significant sideband. Ada 7. Nampak Ada 7 pasang sideband. So ini you kena buat table lah, buat table . Maknanya daripada J0 until J2. Okay. So, ada banyak So, tak apa, kita akan buat. So, maknanya N equal to 7. Okay. So, you need to draw a table. So, let's draw a table. Kita buat pelan-pelan So, dia Jn, and di sini so Jn kita boleh ni you kena rujuk table rujuk table. So J1 so J0 is equal to minus 0.4. Okay. J1 is equal to minus 0.07. Ini kalau cuba lihat table minus 0.07. Sila lihat table baru you nampak. Ni sebab saya dah lihat table tadi So saya terus buatlah. J2 bersamaan dengan minus 0.36. J3 equal to 0.43. J4 is equal to 0.28. J5 0.13. So dalam exam you kena buat laju lah pasalnya dia penat sikit. J6 equal to 0.05. J7 0.02. Nampak Ini kalau jawab soalan ni penat terus. Okay. So the question asks about power. Dia tak tanya amplitude, dia tanya power. So kita kena kira power lah, maknanya power. Okay. So P0 is equal to J0 square multiplied with PC. So ini bersamaan dengan berapa? 0.4 square. Remember that PC, how much is PC from the question? The question, okay, back to the question. So PC is equal to 5 watt dalam soalan. 5 watt. Okay, 5 watt. So negative 0.4 square multiplied with 5, you will get 0.8 watt. Okay. And then from here you can LSB dan juga USB lah. Okay, LSB dan USB. So this is the center frequency. Center frequency FC is equal at 100 megahertz. Okay. So FM, how much is FM? FM is equal to 10K. Okay. So there's no, this is the center, so there's no sideband. The first sideband is P1 is equal to J1 square times PC. Ni saya buat ringkas lah. Saya sepatutnya you masukkan nombor lah. Maksudnya masukkan negatif 0.07 kuasa 2 darabkan dengan 5 multiplied with PC is 5 PC is 5 watt. Okay. So this is 0.08 0.0245 watt. Okay, and it is located at FC minus FM. So this is 100 mega minus 0.01 mega. Okay, minus 0.01 mega. Kenapa 0.01? Kerana ini adalah 10 kilohertz. So therefore this is 99.99 megahertz. And this is FC plus FM. This is 100 plus 0.01. So this is 100.01 megahertz. Okay, ataupun saya boleh letak sini megahertz lah senang. Okay, so bila atas dah ada ni, so saya buat senang sini watt lah. So saya tak perlu lagi dah tulis dalam dia punya unit sebab kita dah tahu dah. So therefore P2 J1 square PC. So here is J2 square PC. J2 square 0.36 square multiplied with 5 watt. So you will get 0.648. 0.6. Ini boleh cuba 0.648 watt. Okay. And then here is FC plus 2FM. Sorry. LSB minus. FC minus 2FM. So this is 100 minus 2 times minus 0.02 lah. Okay, 0.02. So this is 99.98 megahertz. So here is FC plus 2FM. Here is 100 plus 0.02. So you get here is 100.02 megahertz. Okay. And then P3 is equal to ni saya terus buat lah. Sepatutnya you kena ni saya buat nak cepat saya teruskan maknanya kalau nak cepat P3 is equal to saya terus masukkan 0.9245 ni sepatutnya you kena buat jalan kerja tapi sebab untuk cepat saya akan fast forward saya akan laju sikit So this is
kalau exam tak buat jam kerja tak boleh ke? Ke kena buat juga waktu exam?
Okay, dalam exam kalau tanya saya okay, kalau dalam exam saya cadangan saya untuk baris pertama, untuk baris yang pertama ni buat jalan kerja. Okay, tunjukkan jalan kerja bahawa dia adalah contoh tadi P1 equal to J1 square times PC, FC tolak FM. So kita dah nampak dia punya dia punya general equation lah. Dan untuk baris yang seterusnya kalau you nak buat, you tak perlu buat jalan kerja, terus masukkan nombor pun boleh. Sebab you dah kira guna calculator. So kami fahamlah bahawa pengiraan itu telah dibuat So kalau tanya saya, boleh. But my suggestion, the first row you buat jalan kerja and then the rest masukkan saja nombor-nombornya. Okay, tak ada masalah. Kita boleh flexible. Okay. So P3 di sini saya dapat 0.9245 watt. And then here is 99.97 megahertz. Here is 100.03 megahertz. Okay, and then 0.392 P4 equals 0.392 392 watt. Ni boleh cuba 99.96 megahertz. This is 100.04 megahertz. Here P5. P5 is 0.0845, 0.0845 watt. Okay. Here is 99.95 megahertz. Here is 100.05 megahertz. Okay, P6 is equal to P6 is equal to 0.0125. Okay, and this is 99.94 megahertz. This is 100.06 megahertz. P7, you will get this one is 0.002. Okay, 0.002 watt. Okay, boleh cuba guna calculator. So here is 99.93 megahertz. Here is 100. Sorry. So 100.04 je. 07 megahertz. Okay. So yeah, soalan seperti ini biasanya markah dia besar. So kalau nak buat, saya cadangkan buat satu baris jalan kerja, yang lain masukkan saja nombornya. Tapi make sure nombor je betul lah, jangan salah. Kalau tak habis Okay. So ya, kita nak memudahkan pelajar dengan cara menunjuk baris yang pertama, menunjukkan kamu faham bahawa general equationnya adalah seperti itu. Dan seterusnya you masukkan saja nombornya. Okay. So now we already get the power and also the frequency. Macam mana nak lukis? So sekarang the issue is how to draw. Okay, how to draw. Ni yang penat ni. How to draw, that means again when we draw, kita lukis kita buat hujung ke hujung lah. Sorry. So this is power in watt. Dalam watt dan F in megahertz. Okay. So katalah di tengah-tengah ni FC lah 100 Let's say this is center at 100 mega. 100 mega, you see that from the previous it is 0.8 watt. 0.8 ni boleh kira kata besar lah berbanding dengan yang lain. Okay. So kita agak-agak lah. So we assume that tinggi dia lebih kurang macam ni lah. Okay, lebih kurang 0.8. And then the first sideband, you see that here, the first sideband kalau you lihat dia kecil 0.0245, 0.0. So you agak-agak lah, agak-agak dia dekat sini lah. Somewhere here, 0.0245. 0.0. Okay, so this is 100.01, 99.99. Okay, and then sideband yang kedua, if you see 0.3 0 sorry. Oh, sekejap. Sorry. Ini power silap saya silap. Yeah, I thought this is tak apa. Ini gantikan dengan power lah sepatutnya. So, kalau power bermakna sini adalah 0.8 Oh, betul lah tadi saya buat. Okay. Sorry. Betul lah. Saya pula confused 0.8 watt. Okay, 0.8 watt tadi 0.8 watt. 0.0245. So this is a 0.0245. Betul lah. And then second sideband, kalau dilihat second sideband J tu dia 0.648. Tiba kecil sikit. Maknanya it is somewhere over here. Kalau dilihat di sini aja. Somewhere here lah, 0.648. Ni agak-agak je tak perlu tepat-tepat. Kita agak-agak saja. So ini pada 100.02. This is 99.98. And then what? Then the third sideband, kalau you lihat third sideband is 0.945. Lagi besar. 0.945 maknanya dia lagi tinggi So agak-agak lah dia lagi tinggi sikit daripada yang ni. So 0.945. Okay, so this is 100.03. Ini saya teruskan 100. Kalau 100.04. Sorry, this is here 0.945. This is 99.97. Okay. So kemudian for the fourth sideband 0.392. 0.392 is somewhere over here. So this is 100.04. Agak-agak sini. So 0.392. Okay, 392. This is 99.96. And then we have the fifth sideband. The fifth sideband, if you see the fifth sideband is 0.0845. Kecil 0.0845 is for example tinggi sikit lah, saya agak-agak 0.0845. This is 100.05. Okay, so here is agak-agak di sini. So 99.95, 0.0845. And then the sixth sideband, if you see the sixth sideband is 0.0125. So 0.0125. So rendah lagi 0 point here. 0.0125 is located at 100.06. So here katalah di sini 0.0125 located at 99.94. And then the last one would be the seventh sideband 0.002. 0.002 somewhere over here, 0.002 located at 100.07 mega. Here dia terletak di sini, katalah di sini, so di sini adalah 0.02. This is 99.94, 93 lah, 93. Okay, so something like this. So saya tak lukis guna pembaris, saya terus buat dalam bentuk anggaran. So dia punya tinggi rendah tu kita anggarkan sahaja. Don't use ruler. Agak-agak lah kalau dia tinggi sikit lah, kalau rendah sikit. Something like that. Okay. So you see that I draw correctly. I have 7 pairs of sidebands. I label it correctly. So full marks for this one. Ni biasa kalau soalan penat macam ni, markah dia besar lah. So soalan dia senang, tidak susah, cuma penat. Itu saja. Okay. Do you have questions? If you have question, please ask me now. Otherwise, I will move to the next example. Otherwise, saya akan teruskan. Okay. Okay, the next example, example yang seterusnya pun example penat sikit Okay, tapi tak apa, kita cuba buat. Okay, example 3.11 in FM transmitter, the frequency is changing between 100 megahertz to 99.98 megahertz, 4,000 times per second. The amplitude of the FM signal is 5 volt. Apa maksud dia? So maknanya gelombang itu bergerak, okay. So katalah sini center FC, so dia oscillate oscillate, okay, oscillate from 99.98 until 100 over here. So this is a megahertz, so this is in terms of F megahertz. Okay, and you are given these oscillations happens 4,000 times per second. So maknanya 4,000 times here referring to the modulating signal frequency. And the amplitude of the FM signal is 5 volt. That means this is 5 volt. This is referring to the DC. So how much is carrier and modulating frequency? Carrier frequency is equal to, you boleh tambahkan, okay, 100 plus 99.98 divide with 2, so you get 99.99 megahertz. Okay, so 99.99 di tengah. And then FM is equal to the number of oscillations. Okay, how much is the oscillations? That means 4,000 hertz. Selesai. How much is the carrier swing? So carrier swing is equal to 100 minus 99.98. So this is equal to 20 kilohertz. Okay. And then what? And then find the amplitude spectrum. Macam mana nak tahu amplitude spectrum? So kalau kita lihat di sini, nilai delta, kita boleh cari nilai delta F. So kalau kita nak cari amplitude spectrum, bermakna kita perlu tahu berapakah nilai beta, kita perlu tahu berapakah nilai N. So delta F is equal to carrier swing divide with 2, so we get 10 kilohertz. Okay, 10 kilohertz. And then beta F is equal to delta F over FM. So this is 10 kilohertz divide with 4 kilohertz. Okay, so this is 2.5. So you see that this is equal to 2.5. So if 2.5, that means we're gonna have up to 5 significant sideband. Ni kalau kita lihat table, dalam table ada 2.5. So 2.5 is this one. We get n up to 5 significant sideband. Ada 5 pasang sideband. Okay, that means n equal to 5. Okay, saya kembali kepada slide tadi. N equal to 5. So that means n equal to 5. So if you want to draw the spectrum again, we need to draw the table. So kita penat sikit lah sekarang. Penat mengira. Okay. So kita penat mengira. So sekarang ni kita nak buat table lah. We want to draw amplitude spectrum. So that means when we want to draw amplitude spectrum, first we need to draw the table so that we know how much is the amplitude and how much is the frequency. Okay, so here is Jn. So Jn, remember that kita kalau saya padam nanti. So tadi kita dah lihat bahawa n equal to 5, and then we have seen that kita dah lihat bahawa cat delta f is fm, okay, m is equal to 10 kilo. FC is equal to 99.99 megahertz. Okay, and then we know that VC is equal to 5 from the questions, 5 volt. Now we want to draw the spectrum. So Jn, ini kena lihat table. So dia ada 5 pasang sideband. Okay, that means J0. So here is amplitude. Amplitude in volt. Here is LSB. Over here is USB. Okay, so J0 is equal to minus 0.05. So V0 is equal to J0 multiplied with BC. So this is equal to minus 0.05 multiplied with VC is 5, so we get here is equal to minus 0.25 volt. Okay, minus 0.25 volt, so there's no sideband. J1 is equal to 0.45 from the table. Ini saya dapat daripada table. Dia bukan tiba-tiba muncul. Okay, so V1 is equal to J1 multiplied with VC. So this is 0.45 multiplied with 5. So we get this equal to 2.25 volt. And here is FC. Sorry, saya silap. Tadi silap. Sorry. So J1 is 0.5. Saya silap ini. J1 is 0.5. Okay. So 0.5 multiplied with 5, you get 2.5. Okay, 2.5 volt. And then here is FC minus FM, which is equal to 99.99 minus 0.04. The key here is FM 0.04. FM is, how much is FM? Okay, FM here is, okay, FM 4000 4K. FM 4K bukan 10. So ni silap sikit lah. Ya, ni ada silap. Okay, so minus 0.004 mega. Okay, so ataupun ini adalah 0.004 mega. Okay, so ini bersamaan dengan 99.986 megahertz. So ini you boleh buat megahertz lah. So here is FC plus FM. So this is 99.99 plus 0.004. So this is 99.994 megahertz. Okay, so yang seterusnya you buat, masukkan je lah nombor. I know that this is memenatkan 0.45. So maknanya this one V2 is equal to 2.25 2.25 volt, and here is equal to 99.9. So ini sebenarnya gini ini sebenarnya FC minus 2 FM lah. So ini bersamaan dengan 99.982. This is FC plus 3 FM actually So this is 99.998 megahertz. Okay, kalau tak tulis unit pun tak apa sebab sudah ada unit di atas ni Okay, so saya pergi laju pula lah. So here 0.22. So V2 is equal to, sorry, V3 is equal to 1.1 volt. Here is equal to 99.978. Okay. So here is 99.978. Okay. Over here is 100.006. Sorry, 100.002. Okay. Megahertz. J4 is equal to 0.07, and here is V4 is equal to 0.35. Here is 99.974. 974. This is 100.006 megahertz. And the last one would be J5. So J5 is equal to 0.02. So V5 is equal to 0.1. Okay. And then here is 99.970 megahertz. Here is 100.010 megahertz. So maknanya FC plus ini bermakna di sini adalah FC plus FC minus 2 FM. Here is FC plus FC minus 3 FM, FC plus 3 FM. Here is FC minus 4 FM. Here is FC plus 4 FM. Here is FC minus 4 FM. Over here is FC plus 5 FM. Nampak So ini sebenarnya saya buat ni aja So di sini sebenarnya FC minus 5 FM, FC plus 5 FM. So ini ni kalau you dah terbiasa, you boleh buat dengan laju. Okay. So now belum selesai, kita baru dapat nilainya. So we want to draw. Now we want to draw. Okay, we want to draw the amplitude spectrum. Okay. So belum selesai. So when we draw again, this is about amplitude. So means that amplitude versus F in megahertz. Okay, and the center is located at 99. Here is 99.99. Okay, and you see that 99.99 dia ke bawah sikit maknanya negative 0.25. Okay, and then if you see the first sideband is located at 99.994. Okay, 99.994 with the amplitude of 2.5. Agak-agaklah 2.5 dekat sini 2.5. This is 99.986. Biasa dalam exam kita tak adalah sampai perpuluhan ni menyusahkan dia. Okay, so di sini adalah 99 as for the second sideband is, if you see 99.998 998 with the amplitude of 2.25. 2.25 is somewhere over here, 2.25. Okay, so here is 2.25. Okay, 2.25. Here is 99.982. 99.982. And then you see that the next one, the third sideband is 1.1 volt. Okay, 1.1 volt located at 100.02. 002. This is 1.1. 1.1 volt. Okay, and then over here is 1.1. So this is 99.978. 978. Okay, and then here is the fourth sideband located at 100.06, 0.35. Okay, here is 0.35. Ni pun saya agak-agak 0.35. So this is located at 99.974, 99.974, 974. And then the last sideband located at 100.06. Sorry, I need 006. Okay, 100.01. Okay, 100.01. So over here, the amplitude is 0.1 volt. And over here is 0.1 volt, located at 99.970. Okay. So this is the amplitude spectrum. So draw correctly and label correctly. Correctly means we have 7 pairs of sideband, including the carrier component. So drawing correct, and then label. Remember to label the amplitude. Label also the frequency. Kena ada dua, amplitude dan frequency. Kalau you label salah satu, markahnya tidak penuh. Okay, dia kena kedua-duanya sekali. Okay. And then what? bandwidth by Bessel table and Carson's rule. Dia tanya bandwidth by Bessel and Carson is equal to 2 times n times m. So this is 2 times n here is 5 because we have 5 significant sideband multiplied with 4 kilohertz. Okay, so this is 10, so 40 kilohertz. Okay, 40 kilohertz. And then bandwidth by Carson is equal to 2 times delta F plus Fm. So this is equal to 2 times delta F. Here we already got 10K daripada soalan sebelumnya kita dah dapat 10 kilohertz. And we already know the Fm here is 4 kilohertz. Okay, so 14 times 2, so we get 28 kilohertz. Okay, class, I would suggest you to highlight your final answer so that easy for me to give you marks. Okay, because in the final exam, the student's answer would be anywhere in the page. Kadang-kadang dekat atas jawapannya, kadang-kadang dekat tepi, kat bawah, dekat atas dan berterabur. So in order to make it easy for me to mark your paper, I would suggest you to highlight your final answer. In this case, for example, you boleh buat seperti ini kalau you suka. Ataupun ada juga pelajar yang suka buat hashtag macam ni. It's up to you. That means I know that this is your final answer. Okay. So settle, and then the last question asks average power at the transmitter if the modulator carrier power is 5 watt. Apa maksud dia? Apa maksud dia? Find the average power at the transmitter if the modulator carrier power is 5 watt. Maksud dia modulated carrier power is 5 watt. Okay, so ini sebenarnya dia minta kita mencari power of the transmitter. Remember dalam transmitter ada modulator. Okay, so if I draw, let's say this is a transmitter, and within the transmitter we have a modulator. Katalah saya ada modulator. Sebahagian daripada transmitter ini adalah modulator. Okay, and it is said that the modulated power or the modulated carrier power is equal to 5 watt. Maknanya modulator carrier power di sini, power of the modulator. Okay, power of the modulator is contribute towards 5 watt. Okay. However, we can calculate the total power. Remember yang kita kira tadi total power. Total power adalah bersamaan dengan power yang kita hantar kepada antena. Okay. The total power that we calculate is actually the power that we supplied to the antenna. Bermakna total power di sini adalah transmitter power. Keseluruhan transmitter itu. Okay. So that means P transmitter ataupun P total. Okay. So nak lukis kat mana ni? Ni saya padam lah kat sebelah ini. Sorry saya padam saya padam yang ni lah. Okay, I erase this one. So total power that we learned in the previous slides is actually the transmitter power, the power that we deliver to the antenna. Okay, so dia dalam kes ini bermakna P total, okay, P ataupun okay, P total, okay sorry, P total adalah power yang kita deliver kepada antena, okay, which is the power that we supply to the antenna. Okay, so that means P total is equal to PC. That we remember that the one that we calculate previously. How much is PC? So in this case, PC is equal to VC square over 2R. Okay, so ini bersamaan dengan 5, ini daripada 5 volt tadi So 5 square divide with 2 times R. How much is R? Oh, R tidak diberikan di sini So if R is not determined, assume that R is equal to unity equal to 1. R tidak diberikan. So dalam kes ini kita boleh assume that R equal to 1 ohm. Okay, we assume that R equal to 1. So that means we get here around 12.5 watt of total power. Total power transmitted to the antenna. Okay, so now the question is find the average power at the transmitter, excluding the modulator power. Tidak termasuk modulator power. Total power ini adalah power keseluruhan. So soalan ini sebenarnya dia nak merujuk berapakah power bagi bahagian yang lain Okay, ini kalau saya draw dia nak cari berapakah power, average power di bahagian ini the remaining power, I mean the other power excluding the modulator. Berapakah power yang dihasilkan selain daripada modulator ini? So therefore P transmitter is equal to P total minus P modulator. So therefore 12.5 that we get from the total power minus the modulator carrier power, which is 5 watt. So we get here 7.5 watt. Nampak So total power is the power that we supply to the antenna. Semua sekali Modulator power yang diberikan di sini adalah power yang dihasilkan pada modulator carrier power. So how much is the average transmitter power? We minus the total with the modulator power, so we get 7.5. Okay. Modulator is part of transmitter. Modulator ini sebahagian daripada transmitter. Okay, modulator adalah sebahagian daripada transmitter. So if we know the modulator power, we know the total, so we know how much is the average power for the remaining part that produced by the transmitter. So it is equal to 12.5 minus 5, so we get 7.5 watt. Okay. Ada soalan nak tanya? Do you have question to ask? If you don't have questions, we will move to the next slide. Ada soalan? Kalau nak tanya boleh, kalau tak tanya saya akan teruskan. Okay.
Doktor, saya nak tanya.
Ya.
Macam mana boleh dapat R equal to 1 ohm tadi?
Okay, macam mana dapat R equal to 1 ohm? R equal to 1 ohm, R tidak diberikan dalam soalan. Okay, dalam kes ini saya assume dia bersamaan dengan 1. Dia memang tak diberikan. Okay, dalam soalan R tidak diberikan. So, I assume that the resistance is equal to 1 ohm. Sepatutnya, sepatutnya soalan memberikan nilai R. Sepatutnya. Tetapi dalam kes ini dia tak beri R berapa, so kita assume lah R equal to 1 ohm. Kalau kita tak assume berapa nilai R, kita tak dapat nak kira dia punya power. So we assume R equal to 1. So memang soalan ini tidak memberikan nilai R. Sepatutnya soalan kena ada nilai R. Biasanya kita akan bagilah nilai R tu, biasa kita bagi. Okay.
Okey, baik. Terima kasih, Doktor.
Okay. Ada lagi? Kalau ada soalan boleh tanya. Kalau tidak ada soalan, saya akan teruskan. Okay. Okay. So, the next topic. Ini berkenaan dengan noise. So, sebenarnya noise yang you belajar dalam chapter 2, dia sebenarnya berkait rapat dengan chapter-chapter berikutnya. Okay. Noise ni memang sentiasa ada. Okay. So, in pre-emphasis, de-emphasis. Apa maksud pre-emphasis? Pre-emphasis means that we increase the amplitude. We emphasize. Ini perkataan emphasize. Daripada perkataan emphasize, we make it bigger. Okay. Pre here, ini sebelum proses. Pre here, before. Maksudnya pre is sebelum berlakunya sesuatu proses. Okay. De-emphasize, maknanya kita kurangkan. Tadi kita naikkan, emphasize, we de-emphasize, we reduce it. So that's the word. Okay. So dikatakan di sini kelas, FM signal has a non-uniform distribution of noise. The noise at higher modulating signal is higher in amplitude, and noise is higher in amplitude than the noise at the lower frequency. Apa maksud dia? So, information signal with uniform amplitude will produce non-uniform SNR after modulation. Higher modulating signal frequency have lower SNR than the lower frequencies. So from this picture, dia menunjuk kepada gambar rajah ini. So katalah di sini di bahagian tengah ini adalah, okay. Katalah bahagian tengah ini merujuk kepada carrier center, center of the carrier, and it is said that the noise, okay, remember that so this is FC, bermakna di sini ada depend FC plus FM plus 2 FM plus 3 FM 4 FM and so on. Okay. So dikatakan di sini bahawa lagi besar nilai modulating signal, bermakna dia ada sampai contohnya FC plus katalah plus 5 FM, bermakna lagi besar nilai FM, maknanya dia akan oscillate jauh daripada FC. Lagi besar nilai noise level. So noise level di sini adalah merujuk kepada yang ini, tinggi yang ini. Okay. So lagi jauh daripada FC, bermakna kita punya nilai modulating frequency itu lagi besar lah. Dia boleh berayun lebih jauh. That means it can oscillate further away from the FC. So it is said that the noise level would be higher kalau kita menggunakan FM yang lebih besar. Dan dalam konteks angle modulation, FM dan juga PM, you melihat bahawa nilai nilai carrier amplitude, the carrier amplitude is uniform. Dia seragam. Kenapa seragam? Ini kita boleh kaitkan dengan teori yang sebelum ni. So I go back, saya kembali sekejap, saya nak tunjuk. Mana gambar rajah ni? Ni. Kalau you lihat di sini ni nampak kan? Amplitude carrier yang gambar rajah atas ni, amplitude carrier adalah consistent. Okay, yang mana dia berubah-ubah dari segi dia punya frekuensi dan fasa. Okay, remember dalam angle modulation, carrier amplitude tidak berubah, kekal sama. Cuma yang berubah adalah frekuensi dan fasa. Berbeza dengan AM, amplitude modulation, yang mana amplitude carrier berubah-ubah, naik turun. Ni saya tunjukkan yang gambar rajah lama sekejap. So kita nak belajar, so kita kena ambil masa sikit lah. Sekejap. Berbeza dengan AM, saya pergi kepada AM jauh sikit. Saya lompat jauh sikit. Ni. Okay. Kalau you lihat gambar rajah AM, ni tak kisahlah AM yang mana satu. Gambar rajah AM, nilai amplitude carrier asalnya yang A ni, dia jadi tinggi rendah yang ni, naik turun seperti ini. Dia punya amplitude tu dah berubah-ubah. Berbeza dengan angle modulation for FM and PM, dia punya amplitude of the carrier remains consistent, whereas the frequency and phase rapidly changes. Nampak dia punya perbezaan. Okay. So saya kembali kepada slide yang depan. So saya lompat ke depan terus. Sekejap. Okay. So that's why it is said that the signal is uniform. Okay, katalah dia uniform. So therefore, if you see from here, untuk nilai FM yang kecil, okay, untuk nilai FM yang kecil, kita dapat lihat bahawa ni signal level over noise level lebih besar. Maknanya SNR itu besar, lebih baiklah. Kalau kita menggunakan FM nilai modulating signal frequency yang besar, maknanya noise level akan semakin besar. Katalah di sini saya buat X noise level. And our signal level is here. So therefore SNR adalah tinggi yang ni signal level over noise level menjadi kecil. Maknanya SNR menjadi kecil, which is not good. Okay, so sebenarnya ada kebaikan kalau kita ada beberapa kebaikannya, dan salah satu keburukannya adalah nilai SNR inilah, isu SNR. But we can tolerate these issues by doing additional process. Kita boleh atasi masalah ini dengan melaksanakan proses pre-emphasis and de-emphasis. Kalau kita buat pre-emphasis and de-emphasis, we can compensate the loss and we can increase the SNR. Tujuan pre-emphasis and de-emphasis is to increase the SNR. That's the main reason. Okay, kita perlu buat proses pre-emphasis, de-emphasis in order to improve the SNR. Okay, so how does the pre-emphasis and de-emphasis do the process? Pre-emphasis will do the process. Pre-emphasis will increase. Pre-emphasis, kalau you lihat pre-emphasis, dia akan naikkan selepas sebelum. Okay. The word pre here means that pre-emphasis, we will increase the signal level before the modulation process. De-emphasis, we will reduce, we will reduce the signal level after demodulation process at the receiver. Pre-emphasis berlaku pada transmitter sebelum proses modulation. De-emphasis berlaku dalam receiver selepas proses demodulation. Pre-emphasis kita naikkan amplitude signal, manakala de-emphasis kita turunkan amplitude signal pada kadar yang sama. Ingat sebab tadi pada transmitter kita buat pre-emphasis, kita naikkan amplitude. So kalau kita dah naikkan, bermakna dalam receiver kita perlu turunkan supaya dia menjadi keadaan asal. Kita perlu naik dan turun dalam kadar yang sama. Okay. So therefore, if you see from here, if we increase the signal level, kita akan increase secara linear. Lagi tinggi nilai input frequency, lagi tinggi kadar kenaikan yang kita akan tambah signal tersebut. Okay. Kadar gandaan, maksudnya we will amplify. Actually what we do is we amplify actually. We amplify the signal level to be higher, dan kadar gain ini tidak sama, dia adalah linear. Lagi tinggi, nanti kita lihat kita akan tambahkan dia secara linear. That means dia punya gandaan itu bergantung kepada nilai gain yang tidak sama. Nanti kita akan lihat contoh lah. Okay. So what happen is that we will produce a better SNR. SNR yang dihasilkan itu lebih baik berbanding sebelumnya, especially at higher modulating signal frequency. Okay, so ini nilai FM yang besar lah. Okay, so kita dapat improve the SNR especially at higher frequency of FM. Okay. And if we look from this example, the last one, dalam example ini untuk given a direct FM frequency modulator VCO with a deviation sensitivity K1 1 kHz per volt. So this is at the transmitter we use a modulator VCO. At the receiver we use a phase lock loop FM demodulator pada receiver with a transfer function KD 1 volt over 1 volt per kilohertz. And the following input signals, so kita ada 3 input. First input 1 kilohertz at 4 volt, this is 2 kilohertz at 2 volt, and 3 kilohertz at 1 volt. So dia ada 3 input. Determine the frequency deviations delta F pada output VCO dalam transmitter. And determine also the second part is determine the SNR. If you are given this noise, this is the noise at different frequency. 1 kilohertz frequency, the noise is 0.1 volt. 2 kilohertz, the noise is 0.25. 3 kHz, the noise is 0.5. So you lihat nilai noise itu bertambah-tambah. Okay, so ini adalah keadaan sebelum pre-emphasis, de-emphasis. So what happened? Let's look at the left picture. Gambar rajah di sebelah sini. So ini ada VCO dengan transfer function 1 kHz per volt. You have 3 inputs over here and you want to find how much is delta F at the output of VCO. So delta F is equal to KF multiplied with VM. Okay, so you get here is delta. So here you have a delta F1. Delta F1, KF is 1 volt. KF is 1 kilovolt, 1 kilohertz per volt, multiplied with VM. VM here is 4 volt, 2 volt, and 1 volt. 4, 2 dan 1. Okay, and this output goes to the input of the PLL, phase lock loop demodulator. Ini berada pada receiver, tadi pada transmitter. So find the mula-mula cari nilai voltage-nya. The output voltage is equal to delta F multiplied with KD. Nah, so tadi delta F tadi masuk ke dalam sini, multiplied with the KD adalah transfer function untuk PLL, which is 1 volt per kilohertz. So we need to multiply with hertz in order to find volt. Okay, so we multiplied with delta F multiplied with KD. So we get 4, 2 and 1 volt. So ini pada output PLL. Ini macam ni macam yang asal lah outputnya. And you are given noise, which is this one noise diberikan 0.1, 0.25 dan 0.5 pada frekuensi yang berbeza-beza 1, 2 and 3 kHz. Now the second question asks, find the SNR. Okay, SNR equal to SNR is equal to, so you bahagikan lah, 4 bahagikan dengan 0.1, you get 40 at 1 kHz. The second part is 2 divide with 0.25, ni 2 bahagi 0.25 dapat 8 pada 2 kHz. 1 divide with 0.5, you get 2 at 3 kHz. So kalau you perhatikan nilai SNR berubah 40, 8, 2, which is not good. Okay, makin tinggi nilai FM, okay, makin tinggi nilai FM tadi 1, 2, 3, kalau ada 4, 5, 6, 7 dan seterusnya, dia akan menjadi semakin kecil, which is not good. Itu sebabnya kita perlu ada pre-emphasis and de-emphasis network. Ni saya nak tunjuk tapi dah dekat masa, takut you habis masa, so saya akan tunjuk next week lah yang kanan ini. So saya cuma last So untuk memperbaiki itu, so kita perlu tambah pre-emphasis dan juga de-emphasis network. Ada tambahan. Itu untuk soalan yang ketiga example ini. Okay. Yang mana ditambahkan nilai pre-emphasis and de-emphasis. And what you see is that dia mula-mula dia darabkan so dia jadi 4 Kalau you lihat di sini dia ini darab 1, darab 2 dan juga darab 4 Dia punya gandaan dia berbeza-beza. And then dia punya, and then you get delta F 4 kHz over here. Put inside the KD over here and then delta F multiplied with KD, so you get output for 4 volt at each frequency. And you see that from here the noise is given like this 0.1, 0.25, so you akan dapat SNR 40, 16 dan 8, which is better. Okay, so and then we need to put inside the de-emphasis, so we need to reduce pada kadar yang sama kurangkan gandaan 1, 2 dan 4. So we reduce, we divide with 1, we get 4 volt, divide with 2, we get 2 volt, divide with 4, we get 1 volt pada frekuensi 1, 2 dan 3 kHz. Dan dari segi noise level juga akan dikurangkan oleh de-emphasis which is 0.1, 0.125, 0.1. So ini kita bahagikan dengan 1, bahagikan dengan 2, bahagikan dengan 4. Okay, asalnya ni 0.1 bahagi 1, 0.25 bahagi 2, 0.5 bahagi 4. So dia jadi rendah. So dia punya SNR masih sama. So maknanya signal level dengan noise level kita kurangkan pada kadar yang sama dan nilai SNR menjadi sama, tidak berubah, iaitu 40, 16 dan 8. Berbeza dengan tadi 40, 8 dan 2, which is not good. So we achieve a better SNR with the pre-emphasis and de-emphasis network. Okay, ini nanti mungkin saya akan explain lagi pada minggu hadapan. Okay, so that's all for today. So you can open your QR code to scan the attendance, okay, and then you can go to the next class. Sorry untuk task yang kedua saya akan berikan secepat yang mungkin. So untuk projek sebenarnya ada lagi satu task. Task yang pertama you sepatutnya hantar pada 4 paling lambat. So siapa yang dah siap, you tak perlu tunggu sehingga 4 hari bulan, tak perlulah tunggu last minute. Kalau dah siap terus hantar. Okay. Dan untuk task yang kedua akan diberikan maybe in this week or maybe next week kita akan berikan task yang kedua. Okay. So you can scan and then you can move to the next class. So see you again next week.
Alright, Doctor. Thank you.
Okay, welcome.
Assalamualaikum.
Salam.
Thank you, Doktor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Terima kasih, Doktor.
Terima kasih, Doktor. Assalamualaikum.
Sama-sama. Salam.
Doktor,
Ya.
saya ada soalan
Okay.
untuk final kan. Soalan yang keluar dalam test akan keluar tak dalam final?
Maksudnya persoalan yang sama?
No, the chapters.
Oh ya, chapternya masih sama. Dalam final kita ada 5 soalan. Setiap soalan 20 markah dan setiap soalan mewakili chapter yang mewakili setiap chapter. So maknanya chapter 1 ada, chapter 2 ada, 3 ada, 4 ada, 5 ada. So kalau you tanya saya adakah subtopiknya sama? Boleh jadi sama. Macam contoh kira power, contohnya dalam noise power itu ada juga nanti. Mungkin dalam FM, dia kalau sebelum ni tanya AM, mungkin dia tanya FM selepas ini. Biasa macam tu, kita tukar-tukar. Tapi dari segi subtopiknya lebih kurang sama. Senang cerita kalau you tanya saya, memang kena tahu semualah untuk final.
Okay.
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 Nanti mungkin saya akan bagi beberapa tips ataupun hints lah untuk final exam. So don't worry.
Alright, Doktor.
Okay.
Okay, thank you, Doktor.
Okay, welcome. Siapa lagi yang belum? Satu orang ni. So 3, 2, 1. Okay, so saya anggap ada satu orang absent. So one people absent. 2. Recording, stop recording.